Welcome to the Wiener Conference Call series. These one-hour, on-the-record phone calls feature leading experts from Harvard Kennedy School who answer your questions on public policy and current events. Wiener Conference Calls recognize Malcolm Wiener's role in proposing and supporting this series, as well as the Wiener Center for Social Policy at Harvard Kennedy School.
Good day, everyone. I'm Ralph Rinaldi from the Office of Communications and Public Affairs at Harvard Kennedy School. I'm also the host of the HKS PolicyCast podcast, and I'm very pleased to welcome you to the first Wiener Conference Call of this academic year. These calls are kindly sustained by Dr. Malcolm Wiener, who supports the Kennedy School in this and many other ways. Today, we're joined by Henry Lee, who is the Yassim M. Jeddah Family Director of the Environment and Natural Resources Program within the Belfer Center for Science and International Affairs at Harvard Kennedy School. He's also the faculty co-chair of the Sustainability Science Program and a senior lecturer in public policy. Henry is the author of recent papers on the US and China, the economic viability of electric vehicles, and he has written or overseen case studies on Iceland's green energy agenda, Argentina's renewable energy program, climate adaptation in South Florida, and the carbon tax in British Columbia. We are so fortunate that he's agreed to share his expertise today with the Kennedy School's alumni and friends. Henry?
Thank you very much, Ralph, and thank you to Dr. Wiener for his generosity in making this possible. I feel very honored and privileged to A, be asked, and B, be the first speaker of this academic year. The topic that has been selected is one that I think is one of the existential issues that we as society are facing. And as I said earlier to some people, that I think that the student interest in this has just gone through the roof in the last 2 years. And I think it's a reflection that this generation understands the importance and significance of the issue. Can I have my first slide? Second slide. I'm going to talk at the beginning a little bit about what is unique about the climate and why it is somewhat of a unique challenge compared to other sources of other environmental problems. Then I'm going to talk a little bit about climate mitigation and adaptation. And then I'm going to touch on about 3 issues that I think don't get enough attention, but I think are going to be very important in this transition. Now, I realize that trying to do climate in 30 minutes is a little bit of a challenge. And therefore, I want to admit right up front that there are a lot of really important issues that I am going to skim over, or in some cases not even mention. And we can, I'd be glad to go into these during the question and answer period. But I am not claiming anything close to comprehensiveness in this talk this afternoon. Next slide. There are a couple of fundamentals that one needs to understand. As many of you know, the Earth's climate has been changing since about 1900. There were years or even decades in which that change slowed down, but then accelerated again in the next decade. And they really can't be explained by natural influences. There have been a lot of deniers who have raised various concerns, and most all of them have been proven not to be valid, that this is significantly human-induced, and it is increasing in its intensity every decade. The reason is emissions of heat-trapping gases from fossil fuel burning and changes in land use patterns. But the thing that people need to understand about climate is that it is very different than every other air pollutant. If you look at CO2 and you look at methane, or you look at nitric oxides, what you find is that when these greenhouse gases get emitted, they go up into the atmosphere, and about a quarter of them stay up there. And they don't stay up there for, a matter of days or a matter of months like particulates or sulfur does. They stay up there for 100 years, 200 years, in some cases 300 years. So you're looking at concentrations, and these kind of pollutants are called stock pollutants, while the particulates are called flow pollutants. So every time you put up more CO2 emissions, you're simply adding to a concentration. And that's very different from any of the other pollutant sources that we worry about. And so if I tomorrow stopped all greenhouse gas emissions, the natural disasters that are coming from the climate problem will get worse for the next 30, 40 years, no matter what actions we take, because the climate system is now working to come to a new equilibrium. And we're only about a third to a halfway through that for what we've already put up into the atmosphere. And everything you add increases the concentrations and therefore increases the climate impacts. Next slide, please. Now, I will admit I'm borrowing a lot here from John Holdren, who is my colleague here at the school, but this is a chart he uses a lot. And I think when you look at, this is a chart of the growth of population prosperity, but looking at energy sources over the last basically 170 years. And what you see is the dramatic increase in fossil fuel use that starts about 1970. So we've gotten about 50 years where we've become highly dependent on fossil fuels. And to put how difficult it is to wean ourselves of these fuels, we were, as the world was about 80% dependent on fossil fuels in 1990. Today, we're 78% dependent on fossil fuels 30 years later. So in 30 years, we've managed to reduce our dependence on fossil fuels by 2%. This should give you an idea of how hard this is to do. And the reason is that fossil fuels are a terrific energy source in terms of energy density. You really can't replicate them. And so it's very difficult to give them up. We've also got a whole industrial organization or establishment built around fossil fuels. And that makes it even harder to give them up. So this is a recent phenomenon of the last 50 years. But to get us to move away from it is going to be an enormous challenge. Next slide, please. What's ahead? Well, absent big emission cuts, we can expect large further increases in heat waves, big expansions in areas burned by wildfires, bigger torrential downpours and more flooding, destruction of most of the world's coral reefs, wider disruption of marine food webs and fisheries, bigger and more intense thunderstorms, tornadoes, more category 3 and 5 hurricanes like we're having as I speak in Florida, further increases in frequency and intensity of droughts. And all you have to do is look at the droughts over the last 5 years to see that that's true. Accelerated sea level rise, about 1 meter, 3.3 feet by 2100. There are a lot of people who think this is low. There are a lot of studies out now that says it probably will be double that. Obviously, that's all uncertain. We won't know till 2100. Falling agricultural yields for corn, wheat, rice, soybeans around the world, and more sickness and death from heat stress, tropical diseases, and as a result, much bigger flows of environmental refugees. Next slide. If the problem is so serious, why has there been so little urgency? Why have we only made a cut of 2% in our dependence on fossil fuel? Well, there are a number of reasons. One is the problem has historically always been in the future. We always think of, oh, climate is a problem for the next generation. Well, now it's not so much in the future anymore. It's with us, and it's only going to get more serious. Second, the pollutant is invisible. It's not like particle matter where you can see it going up the smokestack. Third, the impacts are uncertain, both in terms of when they will occur and in terms of their magnitude. I may be able to tell you what I think some of the impacts will be, but I don't know. And so that uncertainty sometimes is an incentive to hold off making investments because maybe they won't happen. And I give my class the example of the town in Oklahoma that got decimated by a tornado, and it hadn't done any preparations for tornadoes. And the reporter asked the mayor, "Why didn't you make some preparations for this?" And they said, "Well, for the last 60 years, the tornado has always gone 40 miles to the south of us and 40 miles to the north. It never came here, so we never thought we would ever see one. There was just too much uncertainty, so we didn't do anything." But eventually, you all know that that tornado will hit that place. And but that uncertainty causes people to be reluctant to make major changes in the energy system. Fourth, the impacts are likely to be unevenly dispersed across geographical regions. For example, in the United States, Miami is a lot more vulnerable than Pittsburgh. In terms of countries, there are some countries that are on the coast or are heavily dependent on agriculture that are going to be a lot more dependent than other countries. Fifth, climate is a classic global commons issue. Hence, the possibility for countries to free ride on the actions of other countries is large. So if I can get Europe and Japan to do a lot, maybe I don't have to do so much. The problem is you'll never get on top of this question because of the concentration problem I mentioned earlier, unless the world comes together on this, but particularly the larger countries like China, India, Brazil, South Africa, and the United States. And finally, most of the man-made greenhouse gases in the atmosphere were emitted by developed countries, but much of the future impacts will be felt by developing countries that have had little to do with causing the problem. And this issue is a major focus of most of these international conferences. Next slide. So you have three options. The first is mitigation, measures to reduce the pace and magnitude of the changes in global climate. Next slide. Second is to adapt to it, measures to reduce the impacts, build resilience, and protect societal well-being. Next slide. And unfortunately, the third is suffering, societal disruptions that cannot be mitigated and that adaptation fails to avoid. Next slide. So let me say a few things about mitigation. Mitigation will require 3 to 4 times greater investments in renewables. And we're already beginning to see some pushback on the level of today's investments, which are in most parts of the world are no more than 6 to 12%. And there are a lot of countries still out there that have made no investment in renewables. Second, much greater electrification of how we heat our homes and our buildings. And second, how we move people, particularly the emergence of electric cars. Third, much smarter buildings, much smarter electric grids, and much smarter vehicles. We need to have advances in longer term storage. Right now, we can store energy for 3 to 4 hours, but when we're looking at days or weeks, we don't have the technology yet that is commercial to store energy for that length, those length of time. 2 to 7 times more mining and processing capacity for strategic metals. The reason I have such a large range is that there is a lot of effort to try to find ways to make batteries, for example, without cobalt or without nickel or manganese. And there is some promise that we might be able to do this. And finally, major investments in energy efficiency. If you look at all the pathways to net zero, you're going to look at very large investments in energy efficiency so that buildings 30 years from now or 20 years from now are twice as efficient as the ones you see today. Next slide. Investments in clean technologies will have to increase by about 50%. And there's a big question of who's going to pay and where's this money going to come from? Because you're talking about $1.2 to $1.5 trillion a year in additional funding. Second, you need to restructure the electricity grid. Right now, when you buy electricity, about 60% of that price that you're paying is for generation. 20 years from now, about 60% of that price is going to be for transmission and distribution and transformers. And the generation is going to be a much lower part of that, of the cost of electricity. Approximately 75% of the technologies that we will need to reach net zero are going to be developed over the next 25 years. They're not here now. We are getting close in a lot of areas, but we have a lot of work to do in the research and development, demonstration, and then eventual deployment. Increasing the energy efficiency of buildings and transportation systems and industry by 50%. If you don't do this energy efficiency increase, the cost of the transition will be astronomical. So this kind of investment in efficiency is part of every pathway study that you see. And I think that it's almost a requirement if we're going to reach the net zero goals that a lot of our leaders have embraced. And finally, who will pay for mitigation investments in developing countries who are wrestling with poverty, unemployment, poor healthcare and educational opportunities, and cannot afford to divert money from those priority areas to climate mitigation? Who is going to pay? Right now, the developed countries in the North have agreed to do this, but they have not put up more than 15% of the money that they promised 10 years ago. Next slide. Climate adaptation. This is going to be much more of a local issue. Mayors are going to start having to spend a lot more time on climate adaptation because it's part of public safety. Adaptation alone will not work because adaptation measures get costlier and less effective as the impact of climate change grows. So we have to do a lot more in adaptation, but at some point, you just can't adapt to all of the problems that we're going to encounter over the next 3 decades. Adaptation is basically a form of environmental risk management, but it's a lot harder to implement since it's really uncertain what the value of the risk is. So if I'm going to the city council and I say, I want $10 million for education, I can give you a rate of return on that. If I want to get $10 million for public health, I can give you a rate of return on that investment. If I want it for climate, it's much harder because there's a lot more uncertainty. And therefore, it's very difficult to get mayors to move money from education or public health or public safety to climate. And therefore, every one of the cities, a lot of our cities, not everyone, but a lot of them have climate plans, and they're good climate plans, but their problem is they don't have the money to implement it. Next slide. I think mayors are going to have to spend a lot more attention on climate issues, first because of equity concerns. You take, let's say, Miami-Dade. You've got Miami Beach. There are a lot of people who can afford to invest themselves in adaptation. You also got Liberty City, where you don't have a lot of people who can afford to do this. And this basically Miami-Dade County is going to have to make a lot of those investments. Second, investments in public goods such as seawalls or artificial wetlands. It's very hard for any individual to capture the benefits from that investment. So they have to be done by government. And finally, local governments have impact over zoning, public safety, building codes, and in some cases, urban transit. And these responsibilities have a big impact on any type of adaptation program. And those are controlled at the city and local government level. Next slide. If there is a why, well, I think I've covered that. I think I'll move to the next slide. 3 major issues that are relating to the energy transition that I don't think get enough attention. The first is stranded assets and social justice, and I'll say a few words about that. The second is governance itself, and the third is citing. Next slide. We've got a huge fossil fuel infrastructure, which has been developed over the past 100 years. These include facilities to produce, to refine, to transport, and consume fossil fuels. You have whole communities that depend on this industry. Furthermore, you've got huge investments by the oil and gas industry on resources that are still in the ground. If we're going to meet our aspirational climate goals, a lot of this oil and gas has to remain in the ground. So you have a bunch of challenges here. First, who's going to compensate, if anybody, the oil and gas industry for their stranded assets if we move off of fossil fuels in the next 20 years? What happens to the millions of people who are employed in those industries and receive their health care, often receive their pensions from companies who earn the revenues directly or indirectly from fossil fuels? And I guess I would give one other example. Let's take electric cars. And this is, I was talking to one of my colleagues yesterday, and he gave me a rundown on this, and I thought it was a very interesting observation. The internal combustion engine, it has a whole supply chain that is going to disappear if you go to electric cars. All the mechanical engineers that have worked on engines and on cars and on trucks for literally a century, they're going to get replaced by electric engineers. They're not the same people. So the impact of this transition on the auto industry could be huge. And therefore, any energy transition has got to pay attention to social justice and to this stranded asset problem. I don't care whether it's the US or China or India, these social justice issues, these issues of dealing with stranded assets and stranded human assets are going to become bigger and bigger as we try to implement a transition plan. Next slide. Second, another big issue is governance. And I came up with this when I was working on China, but it's also true of most every government in the world. We have a government structure that sets up a Department of Finance, a Department of Commerce, a Department of Energy, a Department of Environment, a Department of Health, and they are fairly stovepiped. And within each of these departments, there are divisions, and these divisions are relatively stovepiped. But climate is an issue that affects every one of these areas. And therefore, it's really hard to have these balkanized governance structures when you're trying to deal with an issue that goes across all of these various areas. And so climate is going to become a huge issue for interagency cooperation, which has not been the rule in most of our government structures. Furthermore, you've got, in most countries, you have a national government, you've got regional governments or provincial governments or state governments, and then you got local governments. And they're not known for coordinating very effectively with each other. And that includes a country like China, in which the mayor, the governor, the regional czar, and the national government are all part of the Communist Party, and people move between them. They have major problems in the incentives that each of these levels of government have, and they don't cooperate very effectively in China. So I think climate is going to stimulate a whole new way of thinking about government structures, because it's going to require a significant increase in the amount of interagency cooperation. Next one. Citing has always been a major issue in terms of energy investments. And when I was in state government almost 45 years ago, I remember writing the initial draft of the state citing law. And I remember thinking about this problem. And I find that a lot of things that I did not think about have come to pass. It's hard to cite. And in the northeastern part of the country, it's very, very difficult to cite new facilities. Now, if you don't like the facilities, if you think, well, we don't want you citing an oil refinery or a nuclear power plant, well, I understand that. But what happens if the citing problems that you see for fossil fuels is also going to be a citing problem for renewables? Remember, renewables take up a lot of land. A wind farm takes up you don't measure it in square feet, or you measure it in square kilometers. Solar it takes up less, but it still takes up whole fields. And so a lot of the land that could be used for other things is now going to have to be used for energy. And there is already pushback on citing. There are groups in upstate New York who see wind farms or solar community utilities, solar facilities, as they have to pay the environmental price. The benefits all flow to New York City. So there's a lot of opposition to these investments there. So you're going to get pushback on renewables. You're going to get pushback on new transmission lines to move that renewable energy. And if you do, you're not going to get these investments put in place in a timely way. So you have to start thinking about how are we going to look at the citing issue if we're going to make all of the investments that we have been telling people that we're going to make in order to get to the net zero goal. So I think citing, which has been has this aura of being a fossil fuel problem, is going to become a non-fossil fuel problem as we move forward. So anyway, this is a drink from a fire hose, and I admit to this, but I think I'm coming up to just exactly at the time I was told I had to end. So I'm very open to questions, and hopefully I'll give you some answers. So thank you very much for inviting me, and it's been a pleasure.
Thank you very much, Henry, for that terrific presentation. Now we're going to open the session up for your questions. So to ask a question, please use the virtual hand-raising feature of Zoom. And please, in true Kennedy School fashion, keep your question brief, and please end it with a question mark. You will be notified via Zoom's chat feature when it's your turn to speak, and make sure you unmute yourself when you hear from the staff. Finally, I think all our participants would appreciate it if you could state your Kennedy School affiliation before your question. Now, I'd like to start things off, just prime the bump a little bit, by asking a question that was submitted earlier by a member of this call. And Henry, that question is, how can we create markets for district-scaled green infrastructure, which would enable community groups, businesses, and cities to partner toward green systems, including clean water, green energy, waste treatment, et cetera?
Well, I'm going to give you an answer that a lot of people will not like and will push back on me. But if you go back and look at the history of electricity, and you go back to 1910, 1915, 1920s, what you find is electricity started out as small cogen facilities that were stuck in the basement of buildings. One of the famous things is Edison got J.P. Morgan to agree to put one of these in his house. And J.P. Morgan, who was really the biggest financier of electricity. I mean, Edison, banker was J.P. Morgan. So Morgan agreed to do this. And 4 days after he did, it blew up his house. So people said, well, this isn't, we're going to go to bigger. So they decided to go to neighborhood utilities. So if you go back to 1920, Chicago had 40 utilities. New York had about the same. And so you had little neighborhood utilities, sort of community scale on steroids at the time. The average cost of power was about 20 cents a kilowatt hour during that period. Samuel Insull, who had been chief of staff to Edison, said, this doesn't make a lot of sense to have all these little guys around. So what I would suggest is that we try to go to larger, but we need to have a load. And so Insull bought up a portion of the Chicago transit system, where that gave you an anchor customer, and started merging some of these little utilities. And so over about a 15-year period, Chicago went from having 40 utilities to having about 3 utilities because of the fact they were able to concentrate the demand. The price of energy went from 20 cents down to 5 cents. And then Insull went even further and concentrated them into larger utilities that you see today, and had the brains at the time to say that this concentration is going to have a lot of pushback. And so he was the first advocate for state regulatory agencies to regulate him, basically. The price eventually went to 2 cents. So there is an argument for this sort of centralization. I look at solar, for example. If you put solar on a roof and you compare that to the cost of solar on a per kilowatt hour basis from a solar field of, let's say, 10 megawatts or 20 megawatts, it is about 25% cheaper than the system on your roof because it's got larger, it has economies of scale. So I am not willing to forego entire economies of scale to go to very small community systems. I think people can do it, and I think it works technically. There's no reason you can't do it. But I remain unconvinced from every study I have seen that this is going to be the cheapest and least expensive option going forward. That doesn't mean you're going to have large 1 gigawatt plants every place. But I think there is some scale, somewhere in the 50 to 100 to 250 megawatt area. And in terms of neighborhoods, that will work. Now, people say, well, why don't we have a lot of decentralized smaller systems? Well, remember, each one, and even on a small system, is going to have an operator. I mean, right now, we have an operator for regions of 6 states, or New York, 1 state, but there are large regions that the operator works. If you go to small, you're going to have an operator in every one of them. And I don't know where you're going to find that. You also are going to have the ability to keep the reliability issues that you're going to get on a lot of little ones may become more serious than you would on a larger scale. So there are a lot of sort of administrative, logistical, as well as economic issues that are going to move you in the same way that people were moved in the 1920s towards a larger scale. I mean, we're not building 10 megawatt offshore wind farms right now. We're building, gigawatt offshore wind farms, and there's a reason for that.
So we have a question from one of our participants, Gary Grimm. Gary, please unmute your microphone and ask your question for Henry Lee.
Yes, thank you. Climate change, at least in the United States, has become sort of a political hot button. Would it be more beneficial to talk about the social and economic impact of extreme weather and sort of tie that to mitigation and correction, things that you talked about?
Well, I think people try. The difficulty you run into is any one weather phenomenon. It's very difficult to say that is because of climate. And we're getting better at this. I suspect 5 years from now, we're going to be able to say climate caused 75% of this. Where you see the direct cause and effect is on looking at decade level weather patterns. So if you're looking at 5 years in which 3 years you get 100-degree temperature in Siberia, that's not because of a isolated weather phenomenon. That's because it's driven a bit by climate. If you look at the fact that you have had 50 of 100-year storms in the last decade, that tells you that there is a problem that is not likely to be just coincidental, that this is driven by climate. But it is difficult to say that the hurricane hitting Florida now is a direct result of the climate phenomenon. Although I suspect the warmer temperatures in the water in the Gulf are a major cause of why these hurricanes are level 3 rather than a level 1. So it's difficult to do. The second problem is it's difficult to get people to stay on the issue. And we discussed this a little earlier, is that let's take Hurricane Sandy, 60 inches of rain in Houston in 4 days. It was by 20 inches, the largest rainfall in US history. Everybody in Houston got really worked up over that this was climate related, that we needed to do, that Houston needed to take actions. They set up a commission. Today, this is not a big issue in Houston. People have moved on. I gave the example of Hurricane Sandy. Hits lower Manhattan. We have a big concern in lower Manhattan about future Sandys. So we're going to raise buildings up. We're going to not develop houses on Staten Island where they were before. We're going to make a whole bunch of changes. And for about 6 months, there was a lot of momentum to do this. I can remember we had several panel discussions at the Kennedy School on this topic. 2 years later, you wouldn't have known Sandy had ever hit New York. All the houses in Staten Island were built exactly where they were before. Same thing in northern New Jersey. So people's memory doesn't last long because it gets diverted into other issues, and they don't. And then they're somehow shocked when it occurs again. Now, I suspect places like Miami are beginning to understand that this is real, but these are more isolated than I would say universal or homogeneous around the country. And so it's hard to sell the urgency of this problem. People say, well, it's a big problem, but it's not as important as inflation. It's a big problem, but it's not as big as a problem as immigration. So we're going to focus on those two, and then we'll get the climate a little bit later. Well, you're not going to have the option to get the climate a little bit later 20 years from now if we don't start now.
Great. So we have another question from a participant, Roxanne Cason. Roxanne, please unmute yourself and ask your question for Henry Lee.
Unmute. How do I unmute? Wait a second.
You are unmuted.
Oh, thank you. Thank you. I guess you heard me ask myself the question. I'm associated with the Women's Leadership Board at the Kennedy School, served as the chair for about 5 years. I am really concerned about all the things that you are discussing. I just want to mention Miami has begun to recognize these issues. We have king tide flooding, etc. So it is quite real for people who are walking in waist-high water with their suitcases on their heads. I have had a question for some time. I had interviewed somebody to work for me for a project that I'm working on, who works for somebody who submits the primary ideas about what the government can do around climate change. And when I asked her, do you run scenario planning? Do you do strategic thinking? Do you do what the costs are going to be? Do you look at net present value? Do you use artificial intelligence to help you think through? And the answer was, no, we don't do any of that. We just give ideas. And so I have pursued that question. Who is, and I hope you are to some degree, looking at real strategic scenario planning about if we do this? And you sort of referenced that about, attention deficit disorder. It's important now, but not tomorrow. But is anybody really looking at and using artificial intelligence to try and figure out what some of the answers are that are solidly based on sort of scientific assumptions that could lead us to be able to do better planning. And the last question I have is it really necessary to cut off all natural gas to people while we build the infrastructure for the green economy? The pain seems to be so fearful and detrimental. I'm just hoping that maybe there is some really smart thinking about how to do this and to guide the government.
Well, let me try to address both of those. In terms of scenario planning, there are a lot of people who do scenario planning, and I don't know how much they use AI, but certainly a number of them have used some forms of machine learning in some of this. There are at least 16 major scenario plans that I know of for the United States. So this is, relatively common. The problem with them is that they all depend on assumptions. Those assumptions may be correct or they may not be correct. And they're very broad. I don't tend to focus on these kind of pathway studies. I kind of think about, how do I reduce the carbon from the building sector? And how do I convince bankers and insurance companies to put up money to help do that? How do I build a grid or start making investments in a grid that can handle 30, 40, 50% of intermittent energy, which is what a lot of the renewables are? So I try to look at how to take one step at a time rather than how do I go from here to the eventual goal? Because I think it will take a lot of little steps, a lot of corrections, because we'll make mistakes. I keep arguing that if you want an R&D program that works, you got to be willing to fail sometimes, because you're going to learn through failures. And what too much of our Congress says, well, if you fail, you're wasting money. Well, no, you're not wasting money. This is how you advance in society. So I'm more looking at, if I was put in a golf analogy, one hole at a time, not sort of what my score for 18 is going to be. And I think it's important to do this step by step. And yes, there are a lot of scenarios planning done, but I don't think it's that helpful in how we're going to eventually get to this goal. I think we have to look at the problems, look at the bigger problems, and focus on how to solve those. And when we get them partially solved, then try to go to the next step and get them more solved and keep on going like this. So I'm much more of a sort of micro focus rather than a macro focus on this. The natural gas issue is a really interesting issue. There are two sides to this. The one side says that we've got a lot of natural gas. It's a lot better than coal. It's a lot better than oil. And we just can't stop using it immediately. We've got to wean ourselves of the natural gas. So we need to increase it in the short term. And then in about 2030, 2035, start decreasing it. And that will allow us to have a much smoother transition. And we can also go post 2035 to natural gas facilities with carbon capture. And that is a best solution to how to meet the goal. There's another group that absolutely dismisses this and says natural gas is a fossil fuel. If you start doing this, we'll use it as a transition. When the transition starts to come in 2035, you're not going to get off of it because you've just put 10 years earlier, millions of dollars into new gas pipelines, millions of dollars into new gas-fired power plants, and we'll be stuck with this. You will not be able to get off of the gas. I don't know what the answer entirely is, but I do know there's a huge division of opinion on this particular issue in the field. I'm not prepared to say that we can realize our goals without maintaining some use of natural gas in some areas over time. And if we move too fast, we're going to create a backlash against the climate programs. and you're going to look like the yellow vest group in Paris, who, when they tried to change policy for climate reasons, at least in part, you had riots in the streets. So I would not ditch natural gas too rapidly, because I think you're going to find that will create very negative consequences. And you're already seeing this in the newspapers this morning here in Boston, where pending natural gas shortages, because we haven't built the pipeline capacity, is going to create the threat of blackouts this winter. And so the Globe was now becoming a lot more moderate on this. Before that, they were into, let's get rid of natural gas. So I'm more with you on this issue, but I will say it is a hugely controversial issue right now.
All right, Henry, we have a question from Marilyn Avril. Marilyn, please unmute yourself and ask your question.
Henry, good to see you. I was a mid-career class of 2000, and I'm an environmental attorney, but it was at the Kennedy School that I became involved with climate change and have been working on it ever since, although mostly at the international level. But let me drop back to the Harvard level. I'm really interested, Henry, in your points, particularly on governance and citing, because those are things that are not about as much in some of the groups that I run around with. And I'm curious to know, I know that Harvard has this great new effort to try to coordinate climate change work across the university, across the different schools. I'm really curious to know what's happening at Harvard and particularly at the Kennedy School with respect to those two issues, the governance and the citing issues.
Well, first of all, Marilyn, it's nice to see you again. I do remember you very well. And I remember just how much you cared about these issues. So it's great to see you on this call. The governance and the citing, I don't sure that, they have been enjoined by Harvard. We did spend time on the threat of flooding and how that might affect new construction, particularly the area just to the east of the business school, which will be this new science complex and the buildings there. And what we found, I was asked to do the study of the surge from northeast storms of water coming up the Charles and flooding the area. And what I found was that wasn't as big a problem as I thought. One, you can drain the Charles if you know this storm is coming and you knew it might be a problem. But the big problem was rain intensity, was the fact that we did not have a system of storm drain system to deal with the intensity that we saw coming. For example, in Harvard Square, we don't have, the main drain runs right past the Kennedy School. And the fact that you can get into it from the Kennedy, the trap door, which only several of us know where it is, but there is one. I've been in there. And it's not sufficient to handle an intense storm. So the Kennedy School gets flooded because of this. Let me say a few words about what Harvard is thinking of doing, because I'm on the committee and have at times co-chaired it, and I'm still one of 6 people who advise the president on this issue. We understand that we have a goal of being net neutral by 2050 and to get free of net fossil fuels by 2026. That goal is no longer valid. We have to do this much earlier. We're going to have to do this by at least 2040 and maybe 2035. So we're now looking at a number of options that will allow Harvard to basically completely eliminate scope 1 and 2 fossil fuels. And we're looking at the number of buildings that are served by our district heating systems. We have one at Blackstone and one in Maytep in Boston. And we have about 550 to 600 buildings that are independent, many of them using natural gas. And we're going to have to get every one of these off of fossil fuels much sooner than we thought. So we're working now this year on looking at the various options. We hope that we would then begin to start looking at ways to implement those options, the selected options in the second year. So by 3 years from now, we will be underway with a plan on how to completely change the entire campus. Now, it's not going to be cheap. We're talking billions of dollars here. We're not talking a couple of million. We are being pushed both by the city of Cambridge and by the city of Boston to realize very, very strict climate goals. And we are working on them significantly. We have considered offsets for the 2026 goal, but they have to be fossil fuel because it's fossil fuel neutral. That's not climate neutral. So they have to have a climate element and a fossil fuel element to them. And I've been the co-chair of that effort. And I went in somewhat ambivalent about offsets. And I've come away after listening to all of the proposals that I've seen, which are quite a few of them, being more skeptical about offsets than I was in the beginning. It's really difficult to prove additionality on offsets. And so maybe you do some of these for a short term, but you cannot depend on offsets in the longer term. We have simply got to wean ourselves of fossil fuels. And we are in the process of starting to do this, but it will be about a 12 to 14 year effort. And I think Harvard's very serious about it. Now, I've been working with President Bacow. I don't know who the new president's going to be or whether he or she will have the same priorities, but I don't think they have a choice. I think the government's going to make them do it.
Adam Finkel is our next questioner. Adam, please unmute yourself and ask your question for Henry Lee. Adam, you there?
Well,
Adam, I think we are unable to hear you, so maybe we can get this sorted out as we go to Maria. Maria, you're up next. Please unmute yourself. Thank you.
Is that okay? Can you hear me?
Yes.
Good. I graduated from Kennedy School in 2003. I was a mid-career, and I work in Peru on environmental issues. And so I'm bringing that perspective to my question. The conservation part of mitigation of climate change. And my question is, we are expecting that, demanding that policymakers and governments and the local people take care of the forests and in the Amazon as a contribution to climate change mitigation. But we were supposed to have in place schemes like RED, which is reducing emissions from deforestation and forest degradation, but that is not really working, and so there are not much incentives. I would like to hear your view on this issue.
First of all, as an aside, I'm just want to say hello to Adam. He was also in my classes years ago. And I'm sorry he couldn't unmute. In terms of deforestation, it's a huge issue, and it leads to this whole tension between fuel and food around the world, where there is this argument that as population increases by 2 billion people, we're going to have more food in order to feed them all. I'm not sure that's correct. And I look at deforestation in the Amazon, it's largely driven by livestock and grazing. And in Brazil, for example, as of 3 years ago, I don't know what it is today, and I'd be really surprised if it's better, given the present administration in Brazil. You're looking at, on average, 3 cows per hectare. I mean, that's ridiculous. You can be much more efficient. And so you've got to put together agricultural policies and agricultural standards that reduce the threat in terms of deforestation, because it's really hard in these countries to enforce it. Enforcement is a really big problem. It's true in Africa. It has been very true of endangered species. You can put all the rules you want, but you still have poachers unless you can have an enforcement ability, and a lot of these countries don't. So I think for deforestation, it is first and foremost an agricultural, driven by agricultural pressures that you can diffuse. And the second is you're going to have to try to find ways to increase your enforcement ability. And in Brazil, this is a huge issue because they've been clearly identifying deforestation as a problem, but the investment in enforcement has been lacking, with some exceptions in some years, but certainly in the last 4 years, it has not been there. And if we lose more than 10 or 15% more of the Amazon, we're going to lose the Amazon. And that is really the lungs of the planet. So this is not a small issue. This is a huge issue. We're also looking at deforestation in other parts of the world, which lead to, again, erosion and landslides and major problems. But I think people understand that they got to do more on it. It's not easy to do, and it doesn't always receive as much attention as it deserves. So thank you for your question.
Well, it looks like we're at time. Thank you to those of you who called in to listen to this first Wiener Conference Call of the semester. And of course, a special thank you to Henry Lee. That was a great talk and Q&A session. The hour just flew by. We look forward to having you all back on the line with us in November for our next call with Professor Megan O'Sullivan. Have a great rest of your day.
Thank you.